Welcome back, Agent. Let's go ahead and explore just a few more examples of web scraping. In this particular example, we're going to scrape an image off a website. So we will be using the Wikipedia article for Cicada 3301. Notice here there's a little logo for it. So that is what we're going to extract from this web page, and we're going to save this logo as a .jpeg file on your computer. So we will inspect this image and see what we can gather. Here I can see there's an image tag, but we don't want to use the image tag because there may be other images on this page, and I only really want one image. Notice how this Wikipedia globe is also an image, and if you scroll down, you may begin to see other images. Sometimes there is, sometimes there isn't, and you can see here there's a little image here for the internet portal, and we don't really want that. So what we will use instead is the class. We will use the class thumb image and see if that works for us. It may work, it may not work, but since there's no ID here, we will go with it instead of using the image or img tag. So grabbing thumb image, we will come back here and start off with the very first step, which is to make a request to the actual website page. We'll type out res requests.get, and we will copy and paste the Wikipedia article URL. And then once we have that, we're going to create a soup. We'll say soup is equal to bs4, beautiful soup, pass in the text of that request, and then type out lxml. So we've created our soup. Now it's time to actually select something from the soup. As we just discussed, we decided that we'll use the class thumb image. And because it's a class, we will say dot thumb image. And it looks like this is what we want. It says cicada 3301 underscore logo.jpg. And if you notice at the src or source of the image, we have some sort of URL here that leads to wherever Wikimedia or Wikipedia is hosting the actual JPEG file. And eventually that's what we want to grab, and we'll make a separate request for that particular JPEG file and then save its raw content. In order to do that, we will create a new variable called image_info, and we'll confirm that image_info is just a list of tags, and it is here. And it's actually, if we take a look at this again, it's just one item in that image, or in that list, I should say. So let's save that first item as cicada. And if we have that tag, here we can see the actual image tag. And because this is a tag, we can make dictionary-like calls for parts of the tag. Notice how the tag has a class, it has some sort of height, a width, and then information about its source or src, and more information about another part of its width. In order to actually grab essentially subsections of this tag's information, you can make a dictionary-like call. So I would be able to type in class here, and it will return back the class, thumb image, or anything that had class equals inside of this tag object. But in reality, if we take a look at this again, what I really want is src or the source. So every image tag in HTML is going to have src or source, and that's essentially telling you where the actual image is being hosted on the website. So we will type out src, and now we have the JPEG location for this image. And note how it starts with 2 forward slashes. If we actually want to make the request, we need to add on https colon to this, or http. Meaning I will say the image link is equal to http colon, and then I will concatenate what this is right here. So I will copy and paste that here. And then if I take a look at my image link, I have this nice URL to grab the image from. Meaning we're going to make another request. Cicada image is equal to requests get, and then pass in the image link, and remember to pass in lxml. And now we have the cicada image. So since we actually have an image, If we take a look at it, it will say response 200. That actually means it's basically a code saying that the response went through, everything was successful. Another code could be 404, meaning URL not found, but in our case it was 200, it was successful, which makes sense because we essentially were already told that that URL existed. If I want to grab the actual content of the image, then I call the content attribute. And you will end up seeing something that looks like this, and this is binary code, meaning if I want to read or write to this, I can use Python's ability of opening and writing to files. However, instead of just a mode of W or R, I'll need to add in WB or RB. Which means the next step is to actually create a JPEG file, write the content to it, close it, and see if it worked. Meaning we will say f is equal to open, and here we're going to create a new file name. So we'll type out cicada image new JPEG, and I will open this file with write and binary permissions. Right now this file does not exist on my computer, so it's going to create that file for me. It's an empty file right now, so I will write out the actual content of the image. Cicada image content. I will write to it. You'll get some sort of number indicating that the write was successful, and then we will close this. And now I will be able to actually search my computer and find this JPEG file, and it will be the picture of that cicada and the logo. So let's open it up by actually using Markdown. We can do this all in the Jupyter Notebook. Click on a cell, go to cell up here, and then say cell type, Markdown. And Markdown cells can actually accept HTML. So we will provide some very simple HTML code here. We'll say image, src, source, and instead of saying this HTTP link or some other online hosted link, I will actually grab the JPEG that we just created. We will copy this string and then paste it here, and then close off this image tag. And if I run this, I should be able to see that cicada image, which means that I was able to successfully write and download and then write to a file the JPEG image that was on that Wikipedia page. So let's quickly go through those steps since it's a little more complicated than a regular scraping job. The first thing we had to do was make the request to the actual URL and then create a soup out of that request text object. Then we had to inspect the page to figure out what we were actually going to select. In real situations, this may take some experimentation. In our case, we went ahead and chose the class. Classes and IDs are always good first starting points. Then, after we got back the list of information tags, we went ahead and grabbed the object from that list, and then we can make dictionary-like calls for the source link, src, for the image itself. We created an image link by adding on HTTP to this to get a full link, made a fresh request, realized that we could get the content from that request, essentially the image itself, opened up a new file, wrote the content of that file, closed it, and then you will find this file saved on your computer in the same directory wherever this notebook is. And recall, if you ever want to figure out where a notebook is saved, you just type pwd, run this, and it will tell you where you're actually saved.